Have you ever wondered if it's possible to leave our solar system? An intriguing question that has sparked our curiosity, stirred our imagination, and propelled our ambition since the dawn of the space age. The concept of journeying beyond the familiar celestial bodies in our solar system has always been a source of fascination. Over the years, advancements in space exploration have brought us closer to this audacious dream. We've landed on the moon, sent rovers to Mars, and probes have even reached the outer boundaries of our solar system. Yet the cosmos beyond remains largely mysterious, a vast expanse of infinite possibilities waiting to be discovered. Our understanding of the universe has grown exponentially, revealing its breathtaking enormity. Space is not merely vast, it's immense, it's colossal, it's truly infinite. And in this infinity, our solar system is but a tiny, infinitesimal speck. While the concept is thrilling, why haven't we left our solar system yet? To understand why we can't leave our solar system, we must first understand the sheer scale of the universe. The universe is not just vast, it's unfathomably large. In fact, the size of the universe is so incomprehensible that it's beyond human imagination. Let's try to get a grip on this mind-boggling scale. Our home, the Earth, is part of a solar system that's tucked away in a tiny corner of the Milky Way galaxy. This galaxy, which is but one among billions, spans about 100,000 light-years across. Now, what is a light-year, you may wonder? Well, it's not a measure of time, as the name might suggest, but a measure of distance. A light-year is the distance that light, moving at a speed of about 186,000 miles per second, can travel in a year. To put it into perspective, light can travel around the Earth 7.5 times in just 1 second. So, a light-year is incredibly vast. And the nearest star to us, Proxima Centauri, is about 4.2 light-years away. That means, even if we could travel at the speed of light, it would still take us a little over 4 years to reach it. But with our current technology, a spacecraft would take tens of thousands of years to make the same journey. The universe is filled with galaxies like ours, each with billions of stars, and they're all moving away from each other. The universe is expanding, and the vast distances between stars are getting even larger. The space between galaxies is so great that even light, which we've established is incredibly fast, takes millions of years to travel from one galaxy to another. Given these astronomical distances, it's not hard to see why leaving our solar system is a daunting task. It's not just about the technology or the time it would take, but the sheer size of the universe itself that makes the idea of leaving our solar system seem like a distant dream. Even if we could travel at the speed of light, it would still take us years to reach the nearest star. This statement underscores the sheer magnitude of the challenge that lies before us. When we talk about space travel, the first and foremost hurdle we face is the limitation of speed. At present, our space travel technology is still in its infancy. The fastest spacecraft ever launched by humans, the Parker Solar Probe, travels at a speed of about 430,000 miles per hour. Yet even at this breakneck speed, it would take us nearly 7,000 years to reach the nearest star, Proxima Centauri, which is just over 4 light-years away. Now let's talk about the speed of light, the universal speed limit. Light travels at an astonishing speed of approximately 670 million miles per hour. If we could somehow harness this speed, it would still take us over 4 years to reach Proxima Centauri. This brings us to the concept of light years, a measure of distance in space. A light year is the distance that light can travel in 1 year, which is roughly 6 trillion miles. So when we say that the nearest star is 4 light-years away, we're talking about a distance of approximately 24 trillion miles. But what does this mean for our dreams of exploring other star systems? Well, in simple terms, it means that with our current technology, interstellar travel is a pipe dream. We're still a long way off from being able to travel at or even near the speed of light. Moreover, even if we could achieve such speeds, we would then face the challenge of time dilation, a consequence of Einstein's theory of relativity. As we approach the speed of light, time would slow down for us relative to those left behind on Earth. This means a journey to a nearby star could feel like a few years for the travelers, but decades or even centuries could pass on Earth. With our current technology, it's simply not feasible to leave our solar system. The dream remains, but the reality is that we're still taking baby steps in our cosmic journey. Space is not a friendly place for humans. This isn't just an expression, it's a cold, hard fact. The environment of space is truly hostile, filled with dangers and challenges that we, as humans, are not naturally equipped to handle. Think about it. We live on a planet that provides us with everything we need to survive. Air to breathe, water to drink, food to eat, protection from harmful radiation. Space, on the other hand, offers none of these. For starters, let's consider radiation. The Earth's magnetic field shields us from the majority of harmful cosmic radiation. But in space, there's no such protection. Prolonged exposure to this radiation can lead to serious health issues, from cancer to degenerative diseases. Even the spacecrafts we build can only offer limited protection. Then, there's the issue of resources. In space, you can't just pop to the grocery store when you run out of food or water. Every single item a crew needs must be carried from Earth. And the farther you travel from our home planet, the more difficult and costly resupply missions become. In the vastness of space, self-sustainability becomes an absolute necessity, but it's a challenge we are yet to overcome. Finally, let's not forget the physical toll on the human body. In microgravity, muscles and bones weaken, vision can deteriorate, and the immune system can be compromised. Living in space for extended periods can have lasting effects on the human body, some of which we are still trying to fully understand. So what does all this mean? It means that space travel is not a walk in the park. It's a dangerous endeavor, fraught with risks and challenges. It requires us to overcome hurdles we've never faced before, to adapt and evolve in ways we never thought possible. But despite these challenges, our fascination with the cosmos continues to fuel our desire to explore. We strive to push the boundaries, to reach beyond the stars. Why, you ask? Because as humans, we are driven by an insatiable curiosity, a thirst for knowledge, and an unyielding spirit of adventure. The risks and challenges of space travel make it a dangerous endeavor, but it's also what makes it incredibly exciting and worthwhile. Space exploration is an expensive venture. It's not just about the theoretical physics or the engineering marvels, but also about the staggering financial realities. Building a spacecraft, even the smallest and simplest one, comes with a hefty price tag. The materials, the technology, the research and development, they all add up. But that's just the beginning. Once you've built your spacecraft, you need to launch it. And launching isn't like putting a letter in the mail. It's a precise, complex operation that requires specialized equipment and highly trained personnel. But let's say you've successfully launched your spacecraft. Now you need to keep it going. Spacecrafts need fuel, and they need maintenance. They're exposed to extreme temperatures, radiation, and the vacuum of space, all of which can cause wear and tear. And if something goes wrong, you can't just send a mechanic. You need to have backup systems and redundancies, and all of that adds to the cost. And then there's the human factor. Long-term space travel means supporting human life in an environment it was not designed for. It means food, water, air, medical supplies. It means systems to recycle waste and to simulate gravity. It means psychological support for the astronauts who will be isolated from their families, their friends, their planet. But perhaps the biggest financial challenge of all is the sheer length of the journey. Space is vast, and even at the speed of light, it would take more than 4 years to reach our nearest star, Proxima Centauri. That's 4 years of costs, and that's just to get there. The return journey doubles that, and while the spacecraft is on its mission, you can't use it for anything else. It's a sunk cost, in every sense of the word. The astronomical costs make space travel beyond our solar system financially unfeasible. It's not just a question of whether we can do it, but whether we can afford to do it. And right now, the answer seems to be no. So, the idea of leaving our solar system remains a dream. A dream that continues to inspire, but also one that reminds us of the daunting challenges that stand in our way. The vastness of space is humbling, an expanse so great that even the speed of light seems meager. Our current technology, while impressive, is still in its infancy, unable to propel us beyond the confines of our solar neighborhood. Then there's the hostile environment of space, a void filled with radiation, extreme temperatures, and the vacuum of nothingness. Lastly, we can't overlook the financial burden of such an endeavor, a cost that could drain economies and create unforeseen complications. Each of these factors alone presents a formidable obstacle, and together they make the prospect of leaving our solar system an uphill task. While we continue to dream and explore, for now, our solar system remains our home.